Now this is again an important question. This has been asked in board exam. So what we are supposed to do, given a function like this, what we have to do, we have to check the differentiability at x is equal to 1 and 2. So first of all, we'll check for x is equal to 1. So we'll find left hand derivative. So left hand derivative means limit h. Whenever you are writing, keep on revising the definition so that think definition in your mind and keep on putting the value. So this way it will help you in remembering the formula. So it was c minus h. So what is c? 1 minus h f of 1 upon minus h. Right? Now let's put the value limit h tending to 0. Now 1 minus h means the value is less than 1. So if it is less than 1, what is my function? X. So in place of x, what will I put? 1 minus h. Then f of 1, where equal to sign is there, just put 1 in place of x. So it is coming out to be 1, right? So it is like this. This will get cancelled and I will get answer as 1. Then next, what we will have, we'll find the right hand derivative. So for the right hand derivative, I'll just write, again think the definition in mind. This is 1 plus h minus f of 1 upon h. This is limit h tending to 0. 1 plus h means now it is greater than 1. So greater than 1, my function is this. So 2 minus, in place of x, I'll put 1 plus h. Minus f of 1 again will come out to be 1 and upon h. Now let's solve it further. This is limit h tending to 0, 2 minus 1 minus h minus 1 upon h. So this will be 2 minus 2 will be 0, minus h upon h will come out to be minus 1. So right hand derivative is 1, left hand derivative, right hand derivative is minus 1, left hand derivative is 1. So we will say since left hand derivative is not equal to right hand derivative, so it means the value of the given function is not differentiable at x is equal to 1. Now let's do it for x is equal to 2. So this is how you have to do it. Although it is appearing to be difficult, but with practice you will find it easy. So keep on revising the definition in mind and putting the value. Practice is the only solution. So limit h tending to 0, f of, now if you have to check at 2, 2 minus h, f of 2, and this is minus h. So let's put it over here. 2 minus h means it is less than 2. So I'll put it over here. 2 as it is. In place of x, I'll put 2 minus h. Keep on putting the appropriate brackets so you will not have difficulty. Now again, equal to 2 means I'll put it over here. 2 minus 2 will come out to be 0. Over here, this is minus h. So if I solve it further, what will I get? I'll get limit h tending to 0. 2 minus 2 is 0 plus h upon minus h. So it is coming out to be minus 1. Then let's find the right hand derivative. So for the right hand derivative, it is limit h tending to 0. This is f of 2 plus h minus f of 2 upon h. Right? So then further, this is limit h tending to 0, f of 2 plus h means it is greater than 2. So now I will put the value in this particular function. Wherever I have x, there I will put 2 plus h. So I will just write minus 2 plus 3, 2 plus h, then minus 2 plus h whole square, minus f of 2 is 0 and this is h. Right? Now let's solve it quickly. Over here I will solve. So what we have, this is limit h tending to 0 minus 2. Let's open up the bracket. Plus 3 to 6 plus 3h. Then minus a plus b whole square. So minus 4 minus h square minus 4h upon h. So what will I get? Let's see. This is 6 plus minus 2 will give me plus 4. Minus 4 will get cancelled. 3h minus 4h will give me minus h square upon h. This is limit h tending to 0. Right? So now let's quickly solve, take common. So this is h tending to 0. I'll take minus h common. So 1 plus h upon h. So it will get cancelled. If I put h as 0, what will I get? I'll get minus 1. So over here my left hand derivative was minus 1 and right hand derivative is also minus 1. So it means the given function is differentiable at x is equal to 2. It was not differentiable at 1 but it is differentiable at 2. And what is the derivative? The derivative is minus 1. Question, again a 4-marker question has been asked in board exam. So what it is given? A function is given, we have to check the differentiability at 2. So again, if I have to check the differentiability at x is equal to 2, I'll find the left hand derivative. So left hand derivative will be limit h tending to 0, f of c is 2 minus h minus f of 2 upon minus h. So this will be limit h tending to 0, f of 2 minus h means less than 2. So I'll put it over here. So 2 of 2 minus h whole square minus 2 minus h minus f of 2 means if I put x as 2 over here. So 2 square is 4, 4 into 2 is 8, 8 minus 2 is 6 and minus h. Let's solve it. So this will be 2, I'll open up the square, so 4 plus h square minus 4h minus 2 plus h minus 6 and this is minus h. Over here it is limit h tending to 0, 8 plus 2h square minus 8h minus 8 if I add up these plus h. This is minus h, right? So then let's see what we are getting. So this and this will get cancelled. So we will have limit h tending to 0, 2h square minus 7h upon minus h. So we will take h common. So h tending to 0, h common, 2h minus 7 upon minus h. It will get cancelled. If I put h as 0, minus minus will be plus. So it is 7. So my left hand derivative is coming out to be 7. Now let's find the right hand derivative, right? So right hand derivative, I'll just do it here. So it is plus over here, this will be plus, this is right hand derivative. So we don't need all this. So let's see what we will be getting. So if it is greater than this, then what will my function be? So it will be 2 plus h means this now. So I'll just put 2 plus h in place of x. So it is this equal to what we were getting 6 in the previous question, the same thing, previous part. So over here this will be limit h tending to 0, 10 plus 5h minus 4 minus 6 upon h. So this will get cancelled, h and h will get cancelled, I will get 5. So previously I was getting 7, now I am getting 5. Left hand derivative is not equal to right hand derivative. It means the given function is not differentiable at x is equal to. Next, again a very important question. We did this type of question in continuity as well. Sum of 2 mod. So if the question is sometimes an example is asked like give example of a function which is continuous everywhere but not differentiable at exactly 2 points. So what do we give? We can write sum of 2 mods, sum or difference of 2 mods that will always be not differentiable at exactly 2 points. If I write mod x minus 1, mod x plus 1, then 1 and minus 1 will be the points at which it is not differentiable. If I write mod x plus mod x minus 1, then 0 and 1 will be the 2 points at which it is not differentiable. Similarly, if I write x minus 2 and x plus 1, it means 2 and minus 1 will be the 2 points at which it is not differentiable. So this is the most common question that can be asked. Example of a function which is continuous but not differentiable at 2 points, then you can write the sum or difference of 2 modulus functions, right? So over here what we have to do, we have to prove that this function is not differentiable at minus 1 and 1. Let's see how. The same procedure will be followed for n number of questions which you can also make using the sum expression of 2 modulus functions, right? So first of all, let's define these two functions. So it is x minus 1 when x is greater than 1. minus of x minus 1 when it is less than 1. Similarly, mod x plus 1 is x plus 1 when x is greater than equal to minus 1, and minus of x plus 1 when x is less than minus 1. Right? So now again we have to redefine our function. So how we will do? We will look for the smallest condition as we did in continuity. So it is x less than minus 1. Then between condition greater than minus 1, less than 1, and then greater than equal to 1. Over here, just try to observe as we did in this. What conclusion did we draw? Did we draw over there? That if we have plus sign, we will have the same question over here with opposite sign, and it will be an expression in terms of variable x, and this will be a constant. Let's see. For the first part, both will be negative as we did over there. So minus of x plus 1 and minus x minus 1. For this part over here, x is greater than equal to minus 1. So this x minus 1 will be negative, minus x minus 1, and this will be positive, x plus 1. Over here both will be positive. So if I solve this up, what will I get? This will be minus 2x. This will be minus x plus 1. So this will be 2, and this will be 2x. So x less than minus 1, 1 minus 1 x1 greater than equal to 1. If you want to see how we are getting this, if you want to go in detail, just refer the video in which we covered the important questions of continuity. Just check the I button over there. Right? So minus 2x, 2 and 2x over here. Now what we have to do, we have to check the differentiability. So now we have our function like this. We'll check. So left hand derivative at x is equal to minus 1. We'll just use the definition, h tending to 0, f of c minus h minus f of minus 1 upon minus h. So it will be limit h tending to 0 minus h minus 1 minus h means it is less than minus 1. So I'll just put it over there in place of x. And this is f of minus 1. We'll just put minus 1 over here. So it is 2. So minus h. Over there limit h tending to 0 plus 2 plus 2h minus 2 upon h. This will get cancelled. H and h will get cancelled. We will get 2. Right? Then let's do RHD. So RHD is limit h tending to 0 f of 1 plus h minus f of 1 upon h. Right? Now let's, 1 plus h means it is greater than, minus 1 plus h and f of minus 1. So minus 1 plus h means now it is greater than minus 1. So if it is greater than minus 1, what is the function that I have? 2. So at both the places I will write 2. So 2 minus 2 upon h. So it is 0. So left hand derivative is not equal to right hand derivative. It means what? Over here I had minus sign, so this will come out to be minus. Okay, so minus 2 is not equal to 0. So it means left hand derivative is not equal to right hand derivative. Hence function is not differentiable at minus 1. Right? Now this is again a very important question. Now what is given? The function is given to be differentiable at x is equal to 1. What we have to do? We have to find the values of a and b. So now we have, the function is differentiable, we have to find the value of a and b. So whenever the first thing that we will do when we have this type of question, we will say, since f is differentiable, therefore it is continuous at x is equal to 1, because of the result which says differentiability implies continuity. So it means left hand limit is equal to right hand limit is equal to the value of the function. Okay, so left hand limit means what? Left hand limit means x square plus 3x plus a, and right hand limit means it is greater. So bx plus 2 equal to, I will not write because it will come out to be the same. So if I put limit x as 1 over here, so 1 plus 3 is 4 plus a, is equal to what? B plus 2. So I can write it as A minus B is equal to minus 2. Or any way around you want to write, we will just have one relation. This step is very, very important, otherwise we'll be stuck. So next, now we know since f is differentiable at 1, so left hand derivative is equal to right hand derivative. This part we know. So let's find the left hand derivative. So left hand derivative at 1, we will say f of 1 minus h minus f of 1 upon minus h. Similarly, right hand derivative we will say limit h tending to 0 f of 1 plus h minus f of 1 upon h. Now let's put the values over here. So what values will I get? We will get limit h tending to 0. 1 minus h means less than 1. So I'll put it over here in this expression. So 1 minus h whole square plus 3 1 minus h plus a. And what will be f of 1? F of 1 will be, I'll just put the value of x as 1 over here. So what we will get? We will get 4 plus a. If I put x as 1, 1 plus 3, 4 plus a. So it is 4 plus a. And this is minus h over here. So let's solve it. I'll just remove this part. So we will solve it here. We'll just retain this relation. So over here, what we will have, we will just write limit h tending to 0. This is, let's open up the whole square, 1 plus h minus 2h plus this is 3 minus 3h plus a, and this is 4 plus a, right? Over here. Let's then solve. 1 plus 3 is 4 upon minus h. So this is limit h tending to 0. 1 plus 3 is 4. This is minus 5h plus h square, and a I'll write over here, and this is 4 plus a upon minus h, right? So then what will happen? This 4 plus a and this 4 plus a will get cancelled. So we will have limit h tending to 0. I'll take h common. It will be minus 5 plus h upon minus h. This will again get cancelled. What will I get? Because of this minus, this will be 5 over here. So left hand limit has come out to be 5, right? So left hand limit is 5, minus minus will give me plus 5. Now what is next? The right hand limit. So let's find the right hand limit over here. So right hand limit will be limit h tending to 0. 1 plus h means greater, so I'll just put it over here. So it will be b 1 plus h plus 2, right? And f of 1 we have calculated 4 plus a, and this will be h over here, right? So then if I solve it further, what will I get? So we will get this as limit h tending to 0. This is b plus bh plus 2 minus this is 4 plus a upon h. In place of b, what will I write from here? We will write b as a plus, this b will go to that side, so a plus 2 in place of b. This is bh plus 2 minus 4 plus a. So this continuity step is helpful in this particular step for RHG. So 2 plus 2 is 4 plus a, 4 plus a and 4 plus a will get cancelled. Otherwise, if we don't write this step, we'll be stuck. What to do after this? So when we have this relation, we can remove these things from here. So then h and h will get cancelled, and I will get b over here. So what was the left hand side? Left hand derivative was 5. So b is 5. And if I put b, value of b over here in this equation, what will I get? I will get a as 3, right? So a is 3 and b is 5. So these are the type of questions which are usually asked. So these are the questions which are based on definition as well. So stay safe, stay healthy, and keep on solving your problem by practicing at home.